Okay, so this is the Space and the Solar System mission, and it's all about finding new planets and looking for planets that are in the Goldilocks or the habitable zone. So what we thought we'd do with this mission is start off by getting students to think about what it takes to make a planet habitable. And it really turns out to depend very much on the size of the planet, how much sunlight that planet is collecting, or starlight that it's collecting from the star that it's in orbit around. Depends on how big the planet is, and it really has a lot to do with how far that planet is away from the surface of the star. If the planet is too far away from the star is just too dim to provide enough heat to keep water, liquid water, available on the surface of the planet. If the planet is too close to the star, then it's going to be much, much too hot, and any water on the surface is going to evaporate. Now, obviously, water is not the only factor in making a planet habitable, but it's one that we thought we could focus on for this particular mission. Right now, there's a bit of a race on, an international race between different probes, like the Kepler probe run by NASA. There's the HARPS program, the European Southern Observatory has its own hunt on for planets outside the solar system. It's really an exciting age when people have come up with techniques to find planets far, far away from us, in our galaxy still, but very, very distant from our own solar system. So like I say, it's a very exciting time. There's even a planethunters.org, a website that you can go to potentially with your students to see if they can find planets themselves out of some online data. But for this project, what we want to do is get students thinking about what it takes to make a planet habitable. Perhaps they could come up with a model to try to simulate what it's like for a planet to be too close to a sun, too far from a sun, things along that nature. We'd like them to think about what that takes and come up with a proposal so that we could help identify whether planets are going to be in the habitable zones of their stars, or the Goldilocks zones, as we like to call it. Neither too hot nor too cold, just right to sustain life.